All right, everyone, we have finally made it to Trig, which y'all absolutely rocked on our Trig test. And so remember that Trig, whenever we're going to use any kind of trigonometry, we're going to write SOHCAHTOA at the top of our paper. So SOHCAHTOA. I like to go ahead and write all of this out. There's the sine button, cosine button, and tangent button on your calculator. Remember that whenever you're solving for sides, you're going to be using these functions. Whenever you're solving for angles, you're going to be using the inverse functions. And so the first set of directions just says for 19 through 20 to write down just the trig ratios. Remember that the ratios are going to be like a fraction, a comparison of two numbers by division. It's fully simplified. So we're just going to do the ratios. We're not actually calculating any angles here. So what is the cosine of angle x? So from x's perspective, what is cosine? Cosine is always going to be adjacent over hypotenuse. So there's my opposite is 55. So from x, adjacent is going to be 48. Hypotenuse is going to be 73. So that's going to be 48 over 70. Let me write that better. 48 over 73. And I believe that that is fully simplified. 48 over 73. You could type it in your calculator to see, but that is a fully simplified fraction. Now we want the sine of x. What is the sine of x? That's going to be opposite over hypotenuse. So that is going to be 55 over 73. Again, that is a fully simplified fraction. So that's 55 over 73. And then they change perspectives, y'all. We were looking at this through x for the first two. Now we're going to look at this from the tangent of z. So we're changing perspective. So I'm going to erase this, and I'm going to highlight or spotlight angle z's through their perspective. So tangent is opposite over adjacent. And y'all, where I'm getting that is just in this right here. So you're going to have that written out. I like to go ahead and write out the entire phrase instead of just writing O over A. That way I don't have to think about it. So what is for tangent opposite over adjacent? Opposite is going to be 48. Adjacent is going to be 55. So that's going to be 48 over 55. And that is fully simplified as a fraction as well. So let me just make a note here. How do we do this when cosine was adjacent over hypotenuse? Sine was opposite over hypotenuse. Tangent was opposite over adjacent. Number 20 is a little bit harder because it does have a radical for one of our values. And so I do want you to pay attention. The first two are from z's perspective, so we're going to start here. The last one is from x's perspective. So what is the cosine? Cosine is always adjacent over hypotenuse. So there's my opposite. So what's adjacent? 7. What's my hypotenuse? Root 149. So that is going to be 7 divided by root 149. Again, I cannot leave a radical in the denominator, so we're going to rationalize it by multiplying by root 149 over root 149. This is just us simply rationalizing. You end up getting 7 root 149 over 149. That does not simplify anymore, so that looks super, super complicated, but the process is the same. Fully simplified. It's fully simplified. Okay, so what is the sine? The sine is going to be 10 divided by root 149. Again, we rationalize the denominator by multiplying by root 149 over root 149. You end up getting 10 root 149 over 149, and that does not simplify anymore. So 10 root 149 over 149. So it looks super scary, but y'all ready for a much easier one? Let's go from the tangent of x. So we're changing perspectives here. From x's perspective, from x's eyelids, I'm going to put an arc right here. What is going to be our opposite over our adjacent? Because this one was opposite over hypotenuse. So what's our opposite over our adjacent from x? Opposite is 7. Adjacent is 10. That is fully simplified, and I am done. So those are just our tangent ratios. The next set of directions says to find the indicated value, round the lengths to the nearest tenth, and round the angles to the nearest degree. So for number 21, I am finding S. So the first thing I'm going to do is I'm going to scribble out T because that's on there as distractor information. We could find T, but it doesn't ask us to, so I'm just going to scribble it out. So from 23's perspective, T would have been opposite. So what is S? S is adjacent, and the 34 is our hypotenuse. So we're going to fill this in. It's going to be the cosine of the angle, which is 23 degrees. From 23's perspective, what was its adjacent? It was S. What was its hypotenuse? It was 34. When you are solving for a side length, you're going to be using what we call normal trig, the normal sine, cosine, and tangent buttons. We're going to put this over 1, and we're going to cross multiply. So when I cross multiply, S is already going to be by itself. That's going to be 34 times the cosine of 23. So I'm just going to type that into my calculator. 34 times the cosine of 23. Again, making sure your calculator is in degrees. That is going to be to the nearest tenth, since this is a side length, 31.5 31.3 degrees. I'm sorry, not degrees, 31.3 as a length approximately. So the only thing I want you to do is go ahead and plug that in and make sure that makes sense as an answer. Is 31.3 less than 34 like I anticipated? Yes, it is, because that is a side length. It's less than the hypotenuse. For number 22, we're solving for r. So again, I'm going to scribble out s. I don't need it. It's on there as distractor. So from 36, that would have been my opposite. So what is my r? R is adjacent. What is my 5? That is my hypotenuse. So again, that's going to be another cosine. I'm solving for a side length. So the cosine of 36 is going to be the adjacent to 36, which is r, over the hypotenuse of 36, which is 5. Again, I'm going to put this over 1 and cross multiply. When I do that, r is already by itself. And that's going to be 5 times the cosine of 36. When you do that, you're going to get, let's see, again, this is a side length, so I'm going to round that to the nearest tenth. That's going to be about 4.0. Does that make sense as an answer? Is 4.0 in fact less than 5 like I anticipated for the hypotenuse? Yes, it is. Number 23. Number 23, we're solving for angle B. As soon as you see that we're solving for an angle, we know we're going to be using some inverse trig. And so here's what that means. From this angle, my 10 is my opposite, my 15 is my hypotenuse. So I'm going to be using inverse sine. To find angle B, it's going to be the inverse sine of opposite over hypotenuse, so 10 over 15. So we just type that into our calculator by clicking second sine, 10 divided by 15. This is actually way easier than having to cross multiply. Angle B, we're going to round it to the nearest whole number because it says round the angles to the nearest degree. That's going to be about 42 degrees. About 42 degrees, which does make sense as an answer because it's an acute angle in this right triangle. Ooh, another inverse trig. How do I know that? Because it says angle Z. So from angle Z, I'm solving for some inverse trig. That would be my opposite. It's blank. So 18 is my adjacent. 25 is my hypotenuse. I call this the crocodile because when you highlight these pieces that frame angle Z, it makes a crocodile's mouth. Crocodile starts with a C. This is going to be cosine. So adjacent and hypotenuse goes with cosine. So angle Z is going to be equal to the inverse cosine of its adjacent, 18, over its hypotenuse, 25. And I just type that into my calculator, 18 divided by 25. Inverse cosine of 18 divided by 25. This is going to round to about 44 degrees. This is about 44 degrees. So those are actually easier when you're solving for an angle. Let's go again from angle A, inverse trig. From angle A, 5 is my opposite, 11 is my adjacent. So angle A is going to be equal to some inverse tangent. Inverse tangent of opposite 5 over adjacent 11. So second tan, 5 divided by 11 is going to give me about 24 degrees when I round it to the nearest whole, which does make sense as an answer. That is an acute angle. Now number 26 is again solving for a side length. So I'm going to scribble out K. They don't ask me for K. So I know I'm going to be using normal trig. The opposite of 40 is blank. I need J, which is hypotenuse. 10 is adjacent. I'm going to be using some cosine. So that's going to be the cosine of 40 degrees is equal to 40's adjacent, which is 10, over 40's hypotenuse, which is J. Now we do put this over 1 and we're going to cross multiply, but watch what happens when you cross multiply. J ends up getting attached. J times the cosine of 40 is going to be equal to 1 times 10, which is 10. So what is to get J by itself, what's the opposite of times cosine of 40? We're going to end up having to divide both sides by the cosine of 40. So this ends up being a division problem. So you type in 10 divided by the cosine of 40. That's going to give you about 13.1, rounded to the nearest tenth for a side length. Does that make sense? If the hypotenuse is 13.1, is that bigger than 10? Yes, it does. So we're making sure our answers make sense. All right, solving for another side length, we're solving for T, so let's scribble out S. Don't even be distracted by that. So from 25, T is my opposite. From 25, 18 is my hypotenuse. So I'm going to be doing sine of 25 degrees is equal to the opposite of 25, which is T, over the hypotenuse, which is 18. We're using normal trig, so I'm going to put this over 1 and cross multiply. T is going to be equal to 18 times the sine of 25 degrees. And so I'm just going to go ahead and type that straight in. 18 times the sine of 25 is going to be about 7.6. Does that make sense as an answer? Is 7.6 less than the hypotenuse like I anticipated of 18? Yes, it does. All right, number 28. Number 28 is solving for another angle. Which angle? Angle B. So I'm going to be using some inverse trig. So from angle B, 8 is my opposite, 9.2 is my hypotenuse. So for angle B, the measure of angle B, I'm going to be using some inverse sine. It's going to be opposite over hypotenuse. That's going to be 8 over 9.2. So the inverse sine of 8 divided by 9.2 is going to give me about, to the nearest degree, about 60 degrees. It's going to round down to 60 degrees. All right, let's do the last few because we are rolling, friends. I want to find W, which is a side length, so I know it's going to be normal trig. I'm going to scribble out V. So from W, there's my opposite. That makes this the adjacent. That makes the 10 the hypotenuse. That goes with cosine. So the cosine of 70 degrees is equal to its adjacent, which is W, over its hypotenuse, which is 10. Again, we put this over 1 and we cross multiply. So thankfully, W is already going to be by itself. That's going to be equal to 10 times the cosine of 70. 10 times the cosine of 70 to the nearest tenth is going to be about 3.4. Does that make sense? Is 3.4 less than 10 at the hypotenuse? Yes, it is. Now we're solving for an angle, so I'm going to be using some inverse trig from angle B. I've got my opposite as 11. I got my hypotenuse as my 18. So angle B is going to be equal to the inverse sine of its opposite, 11, over its hypotenuse, 18. I'm going to type that straight into my calculator. Inverse sine is going to be, of 11 over 18, is going to be about, to the nearest degree, about 38 degrees. Yep, I did that right, about 38 degrees. 31, we want to find the measure of angle X. So here is X. I can do any trig function I want here because I have the 3, the 4, and the 5. So I like choosing my opposite as my 3. My hypotenuse is my 5. That's just easiest for me to see. I could have gone opposite adjacent. I could have gone adjacent hypotenuse. Those are just the pieces I chose. I chose the 3 and the 5 to work with. And so from there, that is going to be, measure of angle X is going to be equal to the inverse sine of 3 over 5. When I do the inverse sine of 3/5, I'm going to get about 37 degrees to the nearest degree. Okay, I could have used inverse tangent. I would have gotten 37 degrees. I could have used inverse cosine. I would have gotten 37 degrees. Number 32, last but not least, we're solving for y, so I'm going to scribble x out. We're not having to solve for this whole thing. And so from 22, I've got my opposite, and I've got my adjacent. What trig function goes with opposite and adjacent? That's going to be tangent. I'm solving for a side length, so that's going to be normal trig. So the tangent of 22 is equal to its opposite, which is 6, over its adjacent, which is y. I throw this thing over 1 and I cross multiply, but unfortunately, y gets attached to the tangent of 22 by multiplication. That's equal to 6. So how do I get y by itself? What's the opposite of multiplying by the tangent of 22? We divide by the tangent of 22 on both sides. So this ends up being a division problem. You type 6 divided by the tangent of 22 into your calculator, and you get about the nearest tenth, 14.9. So make sure you pay attention to those directions. It says to round the side lengths, normal trig, to the nearest tenth, and the angles, inverse trig, to the nearest degree.